So hey guys, welcome back to this playlist of AI engineering. Okay, so what we are going to learn today is vectors in LLMs. It is very hot topic in LLM right now because it is the base thing. If you don't get what it is, it will be lot of problematic for you to go ahead with the video and understand the topic which are most important for learning the GenAI engineering. So that's why I will highly encourage you to watch this video very concisely, okay, because this is going to be a very important video for this playlist alone. Okay, so in this video we are going to follow this thing, what is the vectors in LLMs, and what is indexing. It is also very necessary. Why do we need it? Okay, why do we need indexing, and what are its type? Vector indexing technique, I mean, what are types of vector indexing techniques. So in this video we are going to uh, go in depth about this all topic. Okay, so in last video we built a RAG application in which we used all of this without knowing, without going in depth in all of this topic. So let me open my text editor and show you what we have done so far. And you can see here we build our simple RAG application which is working, and we can test it out by running this. Okay, I'm going to run all at once, so just for the simplicity, let it run. So here you can see, so day by day, I mean, in further videos we will go ahead and touch this each phase in more depth, because this each phase is very important for your understanding this GenAI engineering part. This is not just about learning how to use LangChain and Lang graph. It is also very important for you to learn how these things works together to build a very GenAI applications, and it contains a lot of part to aggregate this part and build a very robust applications. You must have uh, heard this news, this AI bubble kind of, which company, I think I don't remember the name, but there is a recent news where it came, LLM bubble news. What was that? OpenAI Saltman say AI market is in bubble, and there are a lot of things that going around in the world right now. The companies are using this LLM and building application on it, but some are, there are so much thing that going around here that I think we are not building our application so in the way that we can get more out of it. Okay, which is very important thing to get a profit from. So without knowing this concept like vector indexing and this kind of thing, we cannot create a very good applications. So that's why these topics are very important to understand. So uh, in my playlist, if you go here, we have, I mean, I am lost this kind of videos where I told you about setting the Jupyter notebook and create simple LLM instance, creating a Google Translator. These videos just I created it for your motivation, that so that you can get the grasp, you can get the idea of how these things works together. But now it is time to go in depth in this each topic and learn um, how to build a better application for businesses. Okay, that's why it is very important for you to watch this playlist in very concisely. Okay, so without going in depth, I will start this video and we'll see how this thing works, like what is the vectors in LLM, and what are the parts of it. So you can see the first question is like, what is the vector in vector database? So let me go to my friend, which is ChatGPT, and here I type this, what is the vectors in vector database. It's just simple, and here we got a lot of text here out of it. And you can see in vector database the word vector means numerical representation of the data. Okay, usually a high dimensional array of floating point numbers. We can see here, like a sentence. A computer don't understand the text. Okay, computer do not understand the text, image or audio directly, so we use machine learning models, embedding models, to convert them into vectors. It's fine. uh, it is very common that computer only understand a binary language, and at the end everything converted into the binary. That's the sole root of the computing world. Okay, and there is a, if we talk about higher abstraction, the numbers that the computer understand, it you must, I mean, you must be knowing this thing can convert it into the binary, right? So in the end everything will be converted into the binary. But for the human understanding, for certain software limitations, we need to create a numerical things. We cannot build a software who understand binary, which will be so much complex to build, and will introduce a lot of problems for the developers to build the application. That's why we build this kind of thing, which can be easy for us to build application upon. So you can see a sentence which is simple, nothing but a list of numeric digits, and it which is 768 dimension. It is nothing but it contains 768 characters in it, and also the for this also, like an image can be uh, encoded into this vector representation. For a long time we have already saw there are a lot of encoding and decoding kind of stuff we must have saw, like images can be converted into what is like base 64. That is also called conversion, which is very much important for you, very much important for transferring the data which is image to another source. You cannot just uh, you cannot just send your image which is visually on your screen to another system. Computer cannot understand that image, that is only given to you for understanding it, but computer only understand the numbers. So first it will convert the image into the numbers. Let me show you a little example here. Base 64 image encoder. Okay, and here is the website. You can go onto any website like image to base 64, and here we will convert the image. Let me check this image, and now if we encode the image to base 64, it will give the result in some time. So you can see this is a base 64, and this data we can send from your client to server in any machine, and this text can be copied, and we can also decode base 64 image. We can go to any website, and yeah, I will paste the data here and decode the base 64 image. So it must be downloading. It will download in a little bit time. There are a lot of character you can see, so it will take a little time. So you can see guys, here we got our image. So you can like see here, there is a way we can convert our visual images, which is a 2D actually, to the text which is single dimension, which is easily understandable by the machines. Okay, I mean, it will be transferred via the network protocol bit by bit. This all is what, nothing but a byte. One character is for 1 byte. You must knowing this. Okay, so this is thing that encoding decoding is very important part of the LLM. We will go in depth about LLM in future, where this encoding decoding is a part of transformer, which is very important, where we go to a lot of things like tokenizations happening, and this tokenization convert the each word into a token, which is a number, which is a token ID, and then it is feed to the functions or transformer, which is nothing but our LLM system in future, which is going to be our future LLM systems. So that's why these encoding things are very important. But why, there is a question must be going around your mind, like why we convert this into this vector embeddings, like, I mean, why we convert it into vectors? Why not this base 64? So there is a thing in LLM world. This vector thing can be represent on a 3D plane. If we go here, vector plane, No, this is not vector embedding. We must be getting anywhere. Yeah, you can see here. Let me show you. This is a very correct example. Let me copy this image and paste it in our board. Here is, yeah. So I will paste this image here. You can see this is a 3D plane. This is not just 3D plane. It can be 4D, 8D, 10D, ND kind of plane, where each character, each vectors. Let me open this ChatGPT here. You can see a sentence contain a word. Each word converted into the token, which is nothing but a numerical representation of it. And in vector plane, the bubble you are saying is nothing but those word, which is in form of vector in number. Okay, so the vector is a kind of thing. The special pros, not a pros, significance of the vector is we can like place the word into the plane, which are those words which are most similar to each other, which means the object 2, object 1, object 3, it is not important. If this word contain gives a similar meaning, semantic meaning, then it will be placed together like in cluster. Okay, in cluster together to very in close. Okay, let me show you image one more. Like here you can see. Let me copy this also. This is very important for you to understand it. That's why I'm creating this video. And it's not opening. Let's copy this image and I will paste it here. What is wrong with this? Yeah, why it is not open? Let's take another example. There are a lot of examples we can take. Why we are not getting an example? That image was very good, but unfortunately that was not opening in my computer right now. What is the problem with this, yaar? Why it is not? Why we are not getting any image? I should create an image for you guys. I'm really sorry, but just bear with me. I will find an image quickly for you. So here I take a image from the Google image. You can see here, just understand the thing. Like you can see here we have this 3D plane where this word For demonstration purpose it uses the word, not a numerical representation. But imagine this, this is a numerical representation of this word. You can see the man women are very close to each other, this bubble. Although these are different, you can see like they have different colors, but they are both the same thing. They are human. Man and women are human. Okay, queen and king, this everything is human. So that's why they are very close to each other. They have placed very close to each other in vector database. Okay, and for here also these verbs like walked, walking, and swimming, this kind of verb, these are the verbs. Although their meaning are different little bit, but these are verbs. That's why they are placed very close to each other in a 3D plane in vector database. Okay, and you can see country, capital here also. Although they are capitals and state and whatever it is, but they are something where people live, a land. They all are land. So that's why they have been placed very close to each other. So hopefully you are understanding what is vector and how it working. Okay, so if we go back here, like you can see, it's say example the sentence I love dogs and I adore puppies will have vector close to each other in the high dimensional space. Why? because because I love dogs, I adore puppies. Okay, these words are very similar to each other. If we go um, if we go for more better understanding, sentence transfer Hugging Face model, you will understand why I'm saying this. Or there is a model called BERT model. Okay, we can also use this. You can see if we paste our I love dogs, okay, and compute, let's see what we get. Let's just use sentence transform. I don't know why these things are not working, but let's source sentence I love dogs, I adore puppies. Okay, and if add, we compute, you need to specify at least two comparison. I love puppies, I like puppies. Okay, compute. So you can see thus these sentence have converted into a numerical representation. Okay, which is very close to each other, like very the meaning of this word sentence is very close. Okay, the semantic meaning, it has only a 0.1 decimal difference of. Okay, so that's where the vector is comes into the picture for this kind of features. Means the similar kind of word will be placed in a similar, I mean very close to each other to get a result from. Just for the moment, do not just overwhelm yourself like how this thing were, why we place and how LLM face this kind of word. Just for a moment, just realize, just understand these similar words are placed together in the vector plane. Okay, if I like use this, I hate dogs and then compute. Although the hate is a different meaning here, but this comes from a set of word. I mean this model have been trained. This is also very important for you to understand. Sometimes here you can see the numeric representation is quite same here. I like puppies and I hate dogs. Okay, although this is a different, they gives a very different meaning, but sometimes it depends on the model, like how your model has been trained. If it trained on a certain data set where the hate and likes very like each other, so that's where it is giving, that's why it is giving this kind of result. Okay, so We will talk about this in future videos, like why this is happening. Although the hate and puppies is very different meaning, but it giving kind of similar numeric representation. But also this gives a very sense, like here it is, we are talking about, oh wow, you like puppies, I hate puppies. This kind of communications, conversations are gives the same meaning, like we are talking about what we like, what we don't like. So the sense is pretty same, that's why it is giving the similar kind of numeric representation. Okay, that is a vector. So hope you guys understand what is a vector, okay, which is very important. And which is where we completed our first part. If you do not understand, you can ask in the comment section. And also, if we move ahead with the next point, what is the indexing? So here I open a few blocks. Here I will give the link in description. You can go ahead and watch this uh, blogs, which is very amazing. So you can see here it is saying a vector index is a data structure that enable fast and accurate search and retrieval of vector embeddings from a large data set of object. Okay, so this is very important. I will copy it and paste it here. Okay, so what is this? A vector index is a data structure that enable fast and accurate search and retrieval of the vector embedding. Vector indexing is nothing new. You have saw this. This numerical representation is vector indexing. Like how you are tokenizing the word into the dimensions, that is called vector indexing. The indexing is here specify. I'm giving the stress on the indexing here, which it depend upon the dimension of the vector. Okay, like if we have a dimension of 768, okay, I mean this list can contain 768 numeric digits. Okay, and this vector contain 512 dimension, means it can contain 512 numeric digits in this list. Okay, so that's where indexing comes into the picture, which is nothing but a data structure. Here a list containing the numerical representation of that words. And you can just get an idea from here. Let me show you the image. If I will show you, you can see this is indexing. It depends upon your vector database, like how it is indexing the word, like how what indexing technique you are going to use to create a vector data, to create a vector embeddings for your text data. It depends totally upon you. So that's why this vector indexing is very important. And it is important because if we have less dimension in our sentence, our model, our transformer will not understand the meaning of the text band. Like sometime you will understand. Like let me show you a simple example. What is vector indexing? Let me wait and see what it is saying. So you can see here it is giving a lot of things. Let me simplify for you. So instead of scanning everything, we use indexing, smart data structure and algorithm that reduce the number of comparisons, this kind of thing. Okay, so indexing is nothing but if we convert our data, which is a word here, into this 768 dimension, it will be like really hard for us to it is very hard for our transformer to go into the database and search for the similar word and give result to you. Okay, so that's where it is come. That's where we have an option, like we can reduce the dimension to give a proper to very fast result. If just know here one thing, if dimension is more, you will get a more accurate result. If dimension is less, you will get a less accurate result. Okay, so this is a point. Reduce the number of comparison, still gives a highly accurate result. Make search run in milliseconds instead of minutes. This dimensions increases because our vector embedding model. Remember we used Google generative AI embedding, which is doing nothing. Whatever we created a chunks out of here, we created chunks here, right? This is, it is doing nothing. It's just take this sentence, okay, this is taking this sentence and what is it, taking this sentence and it's taking this chunk and convert into numeric representatives. But while doing this thing, it also store the context. The context is what, just understanding the way the context is very important. We write a sentence, we write a paragraph where each word doesn't mean a separate meaning, but each word has a meaning which is very important for this previous word. Hope you are getting my point. What I meant is every next word is generated from the previous word. Okay, that's why if we increase the dimension of our vector, it will also store the context of the previous word as well, so that it can predict the next word and give you a result. Like GPT, you must have seen, if we type anything, give me next word for below sentence, I love, okay, and let's see what it gives. That depends on context, okay. In like you can use anything, I love you, I love it, I love this, my family, and coding and dog. So it is coming for nothing but a context. This ChatGPT is very smart, it understanding we are talking about a context, that's why it is giving this smile. Hopefully you are getting this. If you're thinking in terms of language model, the highest probability next word is everyday English is you. So how it is getting you? It must, the model which is using the model, the vector embedding model which is used by the ChatGPT must be trained upon the large pool of text where there is the higher number of probability where the I love you is given. That's why it is saying highest probability next word is you. Okay, I hope you are getting my point. So that's where this vector indexing is important. If we increase our vector indexing size, it can store a very large amount of context and it will give a better result. Okay, that's where the indexing is very important, and there are multiple techniques. If we move ahead with the next question we have, why do we need it? So I think I have given the answer of it in the second question. We need it because we sometimes need better result. If we go on this, you can see we have to trade off. If we decrease our vector size, we will decrease our quality as well, but we will increase our speed, we will reduce our memory. If vector size is large, it will increase the quality, but it will lower this speed and memory. So I will copy this link and paste it into description. You can go ahead and look into all of this technique. But let me show you a simple here. There are a lot of technique here it is giving, which is very common technique we commonly use. I mean, our model or vector embedding, sometimes our open source model like sentence transform and all can use like this technique: flat indexing and local sensitive hashing, inverted file index, hierarchical navigable small world, HNSW indexes, and graph also. So these kind of technique that vector embeddings are built upon. So I'm not going to talk about all of this. I will paste the link in the description. You can go ahead and watch everything in detail, which is very important. Flat indexing is kind of brute force here, which is used by any model. Okay, it is nothing but it plays the word like we saw the image before. You can see it do nothing, just similar kind of word which is in blue color here are in blue cluster, and the red word which are nothing but the fruits are in red zone, I mean in fruit cluster, and the sports green are in sports cluster, green cluster here. So that's what this technique do. And these other techniques which are where does it go, locality sensitive hashing, like if we saw image here, you can see we got a lot of things. If we get 4D 3D dimension plane where these bubbles are placed. This can happen due because we maybe have used any other technique for indexing. So that's why the technique is very important. It provide us this thing, the trade-off, like what quality we are getting, what is the speed, what is memory consumption for our resources, like how much memory it will be utilized when you do the searching. So that's why the technique is very important for us to choose to build a vector embedding model which provide quality, speed and memory. The very good vector embedding model the Google uses is BERT. Okay, BERT and GPT, these both are very good embedding model. You can learn about it. You can go on any website here. So you can see these are built upon a transformer as well. You can go ahead and read this thing on yourself. Okay, so that's it. That is what the vector embedding techniques are. And if we move on to the next topic, why do we need it? We saw it because we need it because that is what which gives us a result are nothing but whatever, like we asked here, we ask a question to the here, like give me the next word for below sentence. I love dash dash dash. So how it is giving, it is trained upon like lot huge pool of the data which gives a probability of like you can use you here, like the highest probability is used. But it's not, it is also saying like you can also use I love this, I love my family, coding and dogs. This is giving all the word that it trained upon, not trained or not all word but a few of them to just give a better understanding for you. Okay, so you can understand why we need the indexing for ourselves, for this quality, speed and memory. These factors are very important, what technique we are going to use. Okay, so our next thing is like what are the types of vector indexing. We saw it already, and that's it, guys. But there is one more thing I want to tell you, how this thing, like here in our code we use Google Gemini. Okay, Google Gemini. You can also use open source embedding. I just for a moment I tell you, you can use sentence transformer. In future video I will show you how you can use the Hugging Face vector embeddings. But right now you just understand we can use Hugging Face, which Langchain also provide. You can use Hugging Face vector embeddings model to convert your text into the vector embeddings. But there are multiple things like Qdrant. You must have saw Qdrant. What is it here? Qdrant is nothing but a vector database. It converts the word into a token, basically a vector. Okay, so you can try this out. You can learn little bit about what is vector. And there is another one, Pinecone. These two are very industrial level kind of applications, which is heavily used by production applications. And Postgres also provide PZ vector. You can read about it as well. Okay, so these are the application which is built upon nothing but these techniques we just talked about. What were the techniques? These techniques has been built upon these techniques. Okay, which gives us the better result. Maybe in future video we will talk more about the vector embeddings, but for this video my purpose was to give a better overview of what this indexing is all about. And I hope I am successful in to make you fully understand. Okay, so if you have any doubt, you can just ask me from the comment section below. And the next video I will talk about few techniques like There are multiple way to create vector embeddings. There are multiple tool we can use like FAISS. LangChain provides it, which is nothing but a Facebook AI similarity search, and there is also called Llama Index. Okay, these tools are built upon this technique also. Okay, which is nothing but also these tools are nothing but have been built upon these trade-offs we just saw. Some of them, like sometime the FAISS can provide the quality result, the Llama Index will provide the result in speed more, which is in low latency. So we will saw this kind of tool in the future video, but we learned a lot in this video, and I think which is very much for this video right now. So we will meet soon in the next video, and where I will we will create something using these models. We can use Hugging Face model, and maybe in further video I will use FAISS as well. So see you soon in the next video. तब तक के लिए अगर आपको वीडियो अच्छा लगा हो, if you like the video, don't forget to hit the like button, and if you haven't subscribed my channel and you liking my content, so please subscribe my channel. It will highly encourage me to create such video a lot. Okay, thank you very much guys.